Well, hello and welcome YouTube. Mr. Arms back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Step one aside, we are doing sections 4.1 to 4.5 in our quiz review on those ones from the Big Ideas Math Integrated Math 2 textbook. A lot of things involving quadratics and solving them. We're going to start by simplifying radicals, some of them with variables, sometimes rationalizing the denominator, then solving by graphing, using square roots, completing the square and quadratic formula. We've already solved by factoring in the past from chapter, I think, 2. And then we learned how to graph, and now we're getting all these in a lump sum as a review for any quiz that you take. Maybe this is a quiz that you do take, I'm not sure. Check out the description section down below if you want to get a PDF of this stuff and anything else that I attach for you guys as necessary for the problem set. I think it's 23 problems, and find timestamps for each problem as well if you want to find something particular you're looking for. So without further ado, guys, let's go ahead and take a look at the single page quiz review. I think it should be a quick one. We'll go ahead and find out. Let's start with numbers 1 through 8, where these could go as quick as I'd want them to. I might have to do some teaching along the way, but simplify the expression all from section 4.1, and then we move forward. So we begin with the square root of 112x cubed. Now, the way that I generally talk about these as far as teaching them is treat numbers, do numbers with numbers, variables with variables, like that. Anytime we take a square root of a number, we try and find a perfect square factor that can simplify out of this value. 112 I know for sure can divide by 4 because 100 can divide by 4. So 104 is 4 times 26, 108 is 4 times 27, 112 is 4 times 28. That means there's another perfect square factor in there that can fit. I think 16 is an even larger one. So like this can be root 16 times root 7, I think that is. And the square root of 16 is 4, so there I get 4 root 7. On the matter of x's, pull out perfect square factors of that. The way I'll talk about it this first time is square root of x squared times x. X squared is a perfect square. Take its square root, you get x. And a square root of x stays inside like the other guys, just like the 7. So ultimately, 4 and x are free and outside of the radical, and inside a single radical coming back together is the root 7x. That's how you'd write it. Do you have to do all those steps? Absolutely not. You could do them all in one fell swoop, but numbers do go with numbers, variables with variables, and eventually rationals with rationals and irrationals with irrationals. Let's go to number 2 with the square root of 18 over 81. Those are both inside of the square root. Now, a lot of different ways you can go about this process as well, just like anything else. For one, I could reduce this fraction if I wanted to. But at the expense of, and I don't think it would be a problem, but at the expense of losing a perfect square when I have one, I might as well just work with what I got right now. Let's just play with this, shall we? You can treat these as two separate square roots, just like I did with the product on problem number 1. Notice that I separated this product into two separate parts. Separating a fraction into two separate things is okay as well. And 81 is a perfect square. Why not just work with it while we have it? So this is 9. Now, will I be able to reduce something later? I think so. Square root of 18, perfect square factor is 9, and the square root of 9 is 3, and 9 times 2 is 18, so I get root 9 times root 2, or 3 root 2. Now, 3 divided by 9 can reduce to 1/3, so that's where we can go with this. 1 times root 2 is root 2. I'm left with root 2 over 3. Excuse me. Alternatively, with this problem, what I could have also done, and I know this isn't very good in the way that I'm writing all the different steps here, but what I could have also done was taken this and reduce the fraction to begin with, dividing 18 and 81 both by 9 and getting 2/9 straight up. And look at that. This turns into square root of 2 over square root of 9. Square root of 9 is 3. You get root 2 over 3. I'd say that was easier. What I didn't want to do, and it wasn't a problem here though, was reduce 81 into, let's say I could only divide it by 3. Then I get 27 out. 27 is not a perfect square. I'd have to simplify that radical and then rationalize the denominator, and that wasn't something I wanted to do. Number 3, we got cube root of negative 625. Now you'll learn later in this section how to take square roots of negatives and have imaginary or complex numbers as a result, but you can take the cube root of a negative. Cube root of negative 625 is the same thing as the opposite of cube root of 625. You just kind of turn the whole number's negative. Because you cube a negative, you get a negative, so cube root's going to do the same. Anyway, cube root of 625. Just like we pulled out perfect square factors from the previous problems, we got to find a perfect cube factor here. Now I'm venturing some form of power of 5. 5 squared. Sorry, 5 squared is 25. 5 cubed is 125. So I can factor 125 out of here as a cube root. And 125 times 5 is 625. I think I didn't mention that 625 is 5 to the 4th power as well. Cube root of 125 is indeed 5, and I have that times the cube root of 5 still within. It is negative. That is the final answer for number 3. Number 4, I have 4 over the square root of 11. Off the bat, you would look at this thing and state, well, I can't simplify the square root of 11, so I'm done. And if the square root of 11 was in the numerator, you'd be right. You'd be done. There's nothing you could do. But we don't like, or we don't accept, in terms of simplification, irrational denominators. We need a whole number of some sort down there, a whole positive number. So we're going to rationalize the denominator by multiplying top and bottom by the same value so we don't change this value, or by the same number so we don't change this value. But root 11 times root 11 is 11. And 4 times square root of 11 is 4 root 11. And 4 over 11 also cannot reduce, so that's the result of rationalizing the denominator on number 4. Number 5. That's a bigger set. We have a fraction, we have a cube root, and we have variables. 2 variables, no less. So cube root of 54x to the 4th over 343 y to the 6th. 343 is divisible by, actually it's the cube root, it's 7 cubed. I do know that off the bat. Listen, I'm gonna deal with the bottom first because I feel like these are both perfect cubes. You know when we did the square root of the variable on the first question here, that 3, remember a square root is a second root like this. I could have divided 3 by 2 and gotten 1 with a remainder of 1 and written it like that. I didn't mention that, and I'm going to mention it here and now, mostly because in that denominator, 6 can divide by 3. When you take the cube root, here, let's separate this first. When you take the cube root of a variable, you look to the exponent of that variable and you divide by that exponent. So the cube root of y to the 6th is y squared. You divide 6 by 3. I'll deal with the top in a moment. Cube root of 343 is 7. Cube root of y to the 6th is y squared. On the bottom, I have 7y squared. No cube root anymore. 54 is not a perfect cube, but 27 is, and 27 is a factor of 54. Cube root of 27 times cube root of, not 3, but 2. Goes here. And then, if you want to see this one more time, cube root of x cubed times cube root of x would happen here. X cubed times x is x to the 4th power. Next time I'm going to talk about divide, if it happens, and it doesn't, you could divide 4 by 3 and get 1 with a remainder of 1. Here's what's going to happen on top. Cube root of 27 is 3, and you also got that cube root of 2. Cube root of x cubed is x to the 1st power, and cube root of x to the 1st power is, yes, just that, over 7y squared. And now I'm going to merge things together as I can. 3x can come here on the outside. And then I have cube root of 2x on the inside. And on the bottom, I have 7y squared. So I'm showing many more steps than I would ever do myself. In some ways, I'd probably just go straight from this to the final answer if I kind of knew what I was doing there. I might take a couple steps. But yeah, that's what it cleans up to. If anything could reduce, like x's can't divide with y's and do anything with that. 3/7 is not reducible. I would, and I can't, so I'm going to leave it. Let's go to number 6. 6 over 5 plus root 3. Now, I had just made mention on a previous problem, I believe it was number 4, that you need to rationalize denominators, and that's the case here. But this rationalizing of a denominator is going to be slightly different than the previous one, because multiplying by root 3 over root 3 may make this become 3, but you need to distribute the root 3 into here, and 5 root 3 would appear. So it would just make matters worse. It would make the numbers bigger, and you'd still have a root 3. So what you do in these cases is you actually multiply by the conjugate of 5 plus root 3, which is known as 5 minus root 3. We've seen a lot of plus or minuses with radicals and stuff like that, and they happen to cancel out any radicals that are in there. When I FOIL this thing, it becomes a difference of 2 squares on the bottom. On bottom, you get 5 squared minus root 3 squared. I'll write this first time. 5 squared is 25, and root 3 squared is 3, so you get 22. On top, 6 distributes into here. That's 6 times 5 minus root 3, and that is 6 times 5 minus 6 root 3. So you got 30 minus 6 root 3 all over 22. Because 2 is a common factor on top and bottom, I can divide everything by 2, and that's exactly what I'm going to do. If you're unsure of how that works, take out a common factor. Well, let me just do that. Just divide everything by 2. 30 divided by 2 is 15. 6 divided by 2 is 3. 22, whoopsie. This part doesn't get affected. It's part of the product, and it's in an irrational. A double whammy there. And 22 divided by 2 is 11. There's the reduced version of that. Yes, you still have an irrational value. There's no changing that. It was irrational to begin with. We just rationalized the denominator. And that's your final result. Let's jump to number 7. And on number 7, we have 2 root 5 plus 7 root 10. I did state this can go as quick as I want to make it. I decided not to make it very quick. 2 root 5 plus 7 root 10 minus 3 root 20. You want to treat this almost as if it says like 2x plus 7y minus 3z. That nothing can combine right now. No like terms. But if I can simplify a radical such that, because the reason I said x, y, and z is because these are different radicals. If I can simplify a radical such that I make it look like another one, if I can make this 20 look like root 10 or root 5, I want to go after it, and then I can combine like terms. And I can. So 5 and 10 don't have perfect square factors, but 20 does. You can factor a 4 out of there. I can turn this into 2 root 5 plus 7 root 10 minus 3 times root 20 is 2 root 5. Root 4 times root 5. So 2 root 5 plus 7 root 10 minus 3 times 2 is 6. 6 root 5. And now this is less like 2x plus 7y minus 3z, and it's more like 2x plus 7y minus 6x. Now that they both share a common factor of this right here, you can combine them. Combine like terms. And that's the idea that they want behind the simplification. So 2 root 5 minus 6 root 5 is negative 4 root 5. And because it's negative, I'll just go ahead and write it second. So I'll have 7 root 10 minus 4 root 5. And that's a simplified result of number 7. Number 8 has more of the same. It's a distribution of a monomial into a binomial. Now, in this problem, again, more than one way to do it. Would you rather simplify this radical first? I'm going to go ahead and say yes. If I remember historically with this book, simplifying this radical means these two will combine. Otherwise, I could distribute into here, get 2 terms, and work some things out. But you're left with bigger numbers and a binomial that doesn't need to be. So 7 root 12, you just saw how 3 root 20 turned into 6 root 5. Let's do the same thing in one shot. 7 times root 12. Root 12 is root 4 times root 3, or 2 root 3. We get to multiply 7 by 2 root 3, so we get 14 root 3. Now, if you notice, these both have root 3's in them. So without distributing that root 6 just yet, 14 root 3 minus 4 root 3 is 10 root 3. It's at this point that I get to multiply root 6 by the 10 root 3, which means root 6 multiplies by root 3, and you get 10 root 18. This could be the final answer, but 18 has a perfect square factor of 9 inside of it. Root 18 is root 9 times root 2, or 3 root 2. When you multiply 10 by 3 root 2, you get 30 root 2. And that is the final result of taking that into this. This is why we simplify, because of what it can lead to afterward. This couldn't have been possible if we didn't look to simplification, combining, and further things like that. And we did. That's why we do it, folks. And that is all of section 4.1. A lot of it, but good old quiz review there. Let's go to numbers 9 through 11, where we use the graph to solve the equation. Now, I don't plan on copying down this graph, so I think these will be very brisk problems to talk about. Well, we'll still solve. I forget if in the problem sets I solved using factoring and such. Maybe I can do it just to double check. So here's the thing. When it's set equal to 0, we're trying to find what values of x we get when y equals 0, which is these two. So for this one, x squared minus 2x minus 3 equals 0, it appears that we're going to ultimately get to x equals negative 1 and x equals 3. Now, that's fine. Those are the answers based off the graph. Let's go ahead and confirm that that works by factoring this. This factors into x minus 3 times x plus 1. When x minus 3 equals 0, x equals 3, and when x plus 1 equals 0, x equals negative 1. So if you use the graph to solve, there's the solution set. I'm showing you by factoring that it seems to work. Now, number 10, I can't show that exact same thing that I wanted to, because when this is set equal to 0 for this problem, we're trying to find what values of x makes y 0. And when you look at the graph, you can see that it never crosses the x-axis. graph is telling you that there are no real solutions to this thing. No real solutions. That's the final result. That also means, therefore, that this isn't factorable. Not only is it not factorable, but when we talk about it with quadratic formula stuff, the discriminant's negative. B squared minus 4ac, you're going to get a negative value, so no real solutions. We're going to talk about how complex solutions come out as a result of it, but it never crosses the x-axis, and by looking at the graph, that's what we make a conclusion on. Now, number 11, when set equal to 0, we see where it crosses the x-axis. It only hits once on the vertex, and that's the one solution we're going to get. Based off what you see on appearance, it appears to be x equals -5. Let's confirm that that works. I'll do it by factoring again. For it to be x equals -5, it would have to be a perfect square trinomial of this quadratic, and it is. This thing factors to x plus 5 times x plus 5, or x plus 5 squared. Take the square root of both sides, you get x plus 5 equals 0. The only thing you can square to get 0 is 0, so the only value for x that'll work in x plus 5 equals 0 is x equals -5. The graph confirms. And there you have it, how you can get 2, 0, or 1 solutions and how the graph supports it. That is numbers 9 through 11, section 4.2. Let's go to section 4.3 material where we solve equations using square roots. This is possible when you have the problems that you do have right here. When you have an x squared term or a squared quantity with x in it and no other x's in existence. So long as you can get the variable or squared quantity by itself, I'm dividing by 4, you can take the square root of both sides and be done with it. Now, students tend to still make mistakes. I say that as my students that I've taught for quite a while, that just because you have, like, if I said x squared plus x equals 64, you're like, take the square root, and this is x plus x, or something. I don't know what happens. That's not allowed, guys. You can't do that. All right, how did I finish this thing off? I took the square root of both sides. Square root of 16 is 4, but you can also square a -4 to get 16. We account for both answers. If you solve by factoring, you would see that x plus 4, x minus 4, difference of two squares thing pop up. So don't forget that when you're solving these ones. Number 13, more of the same. -3x squared plus 6 equals 0. Let's solve this guy. Just like before, can't take a square root just yet, at least not with any actual meaning. Let's go ahead and subtract 6 from both sides, divide both sides by -3, and then take the square root of both sides from here. Your goal, again, is to get your squared variable or quantity by itself. You get x is plus or minus square root of 2. Irrational, but real, and 2 solutions. Lastly, number 14 from this set. X minus 8 quantity squared equals 1. As much as someone might want to attempt to, expand this, that would be a disservice to you. You already have a squared quantity with x in it. Take the square root of both sides right now. Right now. Square root of x minus 8 quantity squared is x minus 8. Here you'll get plus or minus the square root of 1, which is 1. Now that I can add 8 to both sides to finish solving this thing, you get x is 8 plus or minus 1. But don't stop there if you can actually simplify this. What is 8 plus 1? What is 8 minus 1? Get me those answers. We get x equals 9 or x equals 7. If it said 8 plus or minus square root of 6, you would just leave it like that. Those are the two answers, but we probably won't round, leave them exact. But here, get those two answers. And that's some section 4.3 for you guys. Let's go to section 4.4 where we solve by completing the square. This is kind of a precursor to what you do when you solve using square roots, meaning once we get into that stage, we'll finish what we just did on the previous problems. So in number 5, we have x squared minus 6x plus 8 equals 0. Now they're forcing solving by completing the square on you, although this is factorable. Technically this was factorable as well, but that was the best method to go. They are forcing you to solve by completing the square, so that we will do. X squared minus 6x. We want to find a value that makes this a perfect square trinomial because 8 was not it. And if 8's not it, then I want to subtract it to the other side and add the same thing here. Because, hey, I subtracted 8 to both sides. Now I got to add a number to both sides. Keep the balance. What do? We take -6 divided by 2, get that value, and take that value and square it. -6 divided by 2 is -3. -3 squared is 9. So we will add 9 to both sides of this equation for balance sake, but what I've created now is a perfect square trinomial. In completing the square, I've created something that I can factor down. What two numbers multiply to 9 and add to -6? This -3 right here, and I'm pointing to it. Literally, that's the one that you're going to look to when it comes to factorization. -8 plus 9 is 1, and we've danced this dance before. It looks just like this problem now in a lot of ways. What's the only difference? That was an 8. This is half of an 8. You're like, 4 is half of 8. Yeah? Did you ever do this? 3 is half of 8. Anyway, nothing else is different, right? I want to take the square root of both sides to solve the rest of this thing. So a lot of what you just saw in the last problem, if you encountered it. We got x minus 3 is plus or minus 1. Add 3 to both sides, and 3 plus 1 is 4. And 3 minus 1 is 2. So slightly different answers, but the exact same idea in what we do there. By the way, I did mention this was factorable. This factors into x minus 4 times x minus 2 equals 0. So that becomes x equals 4 or x equals 2. You might be sitting there going, well, Mr. Robinson, that was faster. Why didn't we solve with that method? Number one, they asked us for completing the square. Not everything's factorable. And if it is, even if it is, you might not know the factorization. You might not recognize that it's factorable. It might be a difficult problem to factor. But more importantly, not everything's factorable. So this is another method to use. And it's the next fastest so long as you have a 1x squared and an even linear coefficient. And we are blessed with that for the next problem. Excuse me, number 16. X squared plus 12x plus 4 equals 0. Not factorable, by the way. So we solve by completing the square. There's also quadratic formula. I prefer completing the square in a setup where you have a 1x squared and an even linear coefficient. As long as you have a 1x squared here, you can use that completing the square process you just saw in the last problem. I'm going to subtract 4 from both sides since it's not the number that makes a perfect square trinomial. Let's find the number that does so we can factor it down into something we can take the square root of. We're going to take 12, divide it by 2, we get 6. Square that, we get 36. Boom, perfect square trinomial. Add 36 to this side, add 36 to that side. We found that number that factors down and pairs down to x plus 6 quantity squared. 6 times 6 is 36, 6 plus 6 is 12. And negative 4 plus 36 is 32. At this stage, we'll solve by using square roots, and this is the moment where you say, aha, it's not factorable, because if it were, we would have had a perfect square value here, and this wouldn't have become irrational. Because it's irrational, that means this is the method that we're going to have to go off of and work it out. So we got plus or minus square root of 32. 32 is root 16 times root 2, or 4 root 2. We got to simplify radicals whenever we can. And subtract 6 from both sides. We get x equals negative 6 plus or minus 4 root 2. Now they do ask us to round your solutions to the nearest hundredth if necessary. I suppose this is that necessity. I don't have my calculator out. Let me get it. 1 second. Got to get my TI-83 virtual emulating calculator. And I'm going to do in my calculator. See, there's no, you might say, where's the plus or minus button in your calculator? If there is one, I don't know. You do negative 6 plus 4 root 2 as one of, because they're two different answers. If you put plus or minus, your calculator's going to go, which answer do you want, you know? Negative 6 plus 4 root 2 is this value to the nearest hundredth, negative 0.34. Or negative 6 minus 4 root 2. Let me write something that looks more like the word or. Or negative 6 minus 4 root 2 is negative 11.66 when rounded. So those are the two approximated answers for that. I don't know if there were any answers before that they asked me to round. No. Nor was anything irrational for solutions. So there it is. All right, let's go to number 7, where we have 4x times x plus 6 equals negative 40. Quite an interesting problem as a whole. No matter which way you go and solve it, you're going to have to expand what's there. I'm seeing something immediately here that I want to take care of and address. Whether you do it now or after I expand is up to you. I'm going to divide everything by 4. This is not just because the completing the square method. I would do this no matter what. If I can make my number smaller to solve, I will. 4 divided by 4 is just that. And negative 4 divided by 4 is negative 10. Now, if I distribute x squared, x into both of these, I get x squared plus 6x. Now, I'll keep the negative 10 on this side. We are using completing the square, and if I add 10 over, that's not the value that makes me a perfect square trinomial. So let's find that value, and let's make sure to do this on this side as well. Okay, we're going to add 9. 9 is half, the square of half of 6. 6 divided by 2, and squared. So this factors into x plus 3, quantity squared, and negative 10 plus 9 is negative 1. Now, here's the interesting part, right? You take the square root of both sides. Take the square root of both sides, but unlike cube roots that have real solutions or real simplifications of cube roots of negatives and same thing with any odd roots, you can't take the square root of a negative and get a real solution out. There are imaginary or complex solutions that we'll start diving into after this quiz, but for the sake of this within scope, we're going to state this is no real solutions. Not only was it not factorable, you couldn't get real solutions out. Imaginary? Sure. By the way, that's not a made-up term. Just not for this quiz. Not for this quiz. All right, let's move on to the quadratic formula for these ones. And again, they're asking us to do it. And there are some problems where I'd say, you know what? I would have wanted to use the quadratic formula for that anyway. So thanks for letting us use it. And that begins, actually that doesn't begin with this problem. This one's also factorable. X squared plus 9x plus 14 equals 0. Oh, my mind wants to do x plus 2 times x plus 7, where we get x equals -2 and -7. Oh, I want that so bad. Can we finish and move on to the next problem? No. We're going to solve using the quadratic formula here, the Q of the F. And in quadratic formula, I like to, first of all, you need to be in standard form. Yes. Set equal to 0. Yes. Reduced, preferred, and we are. Identify A, 1, B, 9, and C, 14. And let's find the discriminant first. The discriminant is found by doing, in the quadratic formula, b squared minus 4ac. b squared minus 4ac. That's 81 minus 56, which is, I don't know, that's why I'm asking you, 25? I believe it because this was factorable. We should get a perfect square discriminant. I'm probably jumping the gun a little bit when I said b squared minus 4ac. Our formula is x equals -b plus or minus the square root of b squared minus 4ac. That's the discriminant, all divided by 2a. So we just found that discriminant. The 25 is the guy that's going to exist inside there for b squared minus 4ac. It's the thing you're going to take the square root of. And the square root of 25 is 5. Quadratic formula is a way of solving any quadratic equation, real or non-real, rational or irrational, much like completing the square. Only as this was an odd number, well, it was factorable, but I wouldn't have wanted to solve by completing the square anyway. I don't want to divide an odd number by 2 and square it. You just get fractions or decimals, and they're not fun. So let's keep solving this one. We're going to get x equals -b, opposite of 9, plus or minus, hey, square root of 25, guys, is 5. Why don't I just start that right now? That's my whole point of writing the discriminant first, saving time and energy. Divided by 2a, 2 times 1, well, that's 2. And in some stages, if this was, say, a square root of 5, I'd be done with this. There's nothing else I could do to clean this up, but it is a 5. So I can do -9 plus 5. I can do -9 minus 5. So -9 plus 5 over 2 is -4 halves, which is -2. And -9 minus 5, I don't know, I think I was going to write an x again. -9 minus 5 divided by 2 is -14 over 2. Which is -7. -2 and -7. Hey, that's what I got right there. That was a lot faster to solve by factoring. I agree. But, just like I said before, not every problem is factorable. Now, this might look like more or less work, because this isn't work, right? That's just showing the formula. This might even look like less work than solving using completing the square. I'd say completing the square is faster work for myself on my end. You had to do some bigger calculation of numbers, and, we had to do this part here. But I wouldn't have wanted to solve by completing the square here, like I said. So it depends on the problem. Everything's problem dependent. Now, there are some times where they'd ask you to solve using any method you'd prefer. It doesn't seem like they're asking you a series of questions on these here. Let's go to number 19, x squared plus 4x equals 1. This is a question that's not factorable, but this is also a problem that I would have preferred to solve by completing the square. I do have a 1x squared. That is even. They did say quadratic formula, so if we're going to use quadratic formula, we got to subtract 1 for both sides. Get this set equal to 0. A is 1, B is 4, C is -1. Let's begin with that discriminant portion of b squared minus 4ac. C is a negative, so when we subtract -1, we get a positive. It's -4 times -1. It's positive 4. So that's 20. This is what goes inside of the square root of your quadratic formula. So let's do the rest. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. I'm fine writing the extra step because I got to do a little bit more here. Root 20 is 2 root 5. So x equals, I'll just write it, Negative 4 plus or minus 2 root 5 all over 2. Everything here can divide by 2. Negative 4 can and 2 can. So we will get negative 2 plus or minus the square root of 5. And that's your final result. So like I said, this wasn't factorable. You can see an irrational solution, which kind of solidifies that. If I wanted to solve by completing the square, and I'll do it really fast here, you can maybe see the difference. Keep the 1 on that side, add 4 to both sides, 4 divided by 2 squared. This factors to x plus 2. Whoops. That factors to x plus 2 squared. And 1 plus 4 is 5. This is where I take the square root of both sides. X plus 2 is plus or minus root 5. And subtract 2 over. Negative 2 plus or minus root 5. So what's the difference there? I don't know. Some people still might prefer the quadratic formula version of that, but you can see it's the same. This one here, you deal with smaller numbers. You do. Notice I had to simplify the square root of 20, and I had to reduce the fraction. Here, I didn't have to do that stuff, so there's one preference for me. Number 20, solve with quadratic formula. So, by the way, I kind of cheated. I did another completing the square. Number 20, let's do a next page. Negative 2x squared plus 7 equals 3x. I can't reduce anything through division. I have to set everything equal to 0. I'm going to get my x squared positive, so I'm going to add this over and subtract 7 over, so I get a positive 2x squared plus 3x minus 7 equals 0. Let's go ahead and solve that guy. This is not factorable. That's going to be me using brain. Not factorable, so quadratic formula is absolutely the go-to I would do for this problem. Bar none. End of story. Let's do it. Let's evaluate the discriminant first of b squared minus 4ac. By the way, do I have to do the discriminant portion first? No. I think it's cleaner work if you do. Even if I don't personally do it, I don't think. Because generally I can do things fast enough that it's not a bother. Anyway, negative 4 times 2 is negative 8. Negative 8 times negative 7 is positive 56. 9 plus 56 is 65. 65 is the value that's going to go inside the square root. 65 is also 13 times 5. And 13 times 5 cannot simplify at all. So, no perfect square factors. So, we go straight into it. X equals, based off this is your A, B, C. That's what we just used. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's not just a 2 anymore. It's 2 times 2, which is 4. And this cannot simplify any further than what you're looking at here. So we are done with the problem at that stage. Negative 3 plus minus 65 over 4. I just realized I'm supposed to round solutions to the nearest tenth. So before I move forward, let's finish this problem. Then I'll go back to, what was it, number 19? That I have to do that? Were there any other answers on the previous set that I had to simplify, reduce, whatever it may be? I'm going to show you the calculator on this one, though, because you have to be careful with order of operations. So make sure that negative 3 plus root 65 and negative 3 minus root 65 exists in the numerator of your problem when you do them. So here's what I'm going to do. I'm going to wrap it around parentheses. Negative 3 plus root 65, which has its own set of parentheses. Divide that by 4. And negative 3 minus root 65, dividing that by 4 as well. Here are the two answers I'm going to write down. They did say nearest tenth. So this is about 1.3. I wonder why they say nearest tenth and not nearest hundredth. Maybe just for practice. And then this other one, negative 2.8. That's the nearest tenth for those. Let's see which other problems, because we did have that negative 2 plus or minus root 5. Okay, that was no real solution. I think it was just this one. So this was still in the quadratic formula set. Let me just do this really quickly. Negative 2 plus root 5 is to one decimal place, 0.2. And negative 2 minus root 5 is negative 4.2 when rounded. That's why I say approximately. I want to make sure I didn't miss anything else. We're good. We're good. Okay. So that was number 20 right here. We have 3 more questions to do, and didn't beat the half-hour mark. Did a little too much teaching. Number 21, which method? Oh, here we go. Oh, section 4.5, I forgot, did ask you a lot of questions like that. So which method would you use to solve 2x squared plus 3x plus 1 equals 0? Explain your reasoning. Well, I would love to factor anything that's factorable. And guess what? I think this is factorable. Let me show you all the different methods. This factors into 2x plus 1 times x plus 1. How do I know that? I've done this a long time. 2x squared plus 2x plus 1x is 3x plus 1 is that. So I prefer solving by factoring. I don't like to solve by graphing in this thing if that's kind of one of your options. I'm talking about the algebraic ones. So x is negative 1/2 and x is negative 1 are your two solutions. Solving by factoring and zero product property is my go-to. Let me just kind of star it. Why? Because I'm good and fast at it. If it's factorable, that's what I like to do. Let's do it by completing. Well, you know what? Let's do it by quadratic formula. That would be my next go-to. If it wasn't factorable, I would do quadratic formula. If I wasn't sure if it was factorable, I would go to quadratic formula. I would try to factor. The discriminant, let's begin with that because it's already set equal to 0. We got b squared minus 4ac. See, I make quadratic formula slightly more appealing than it looks by doing the discriminant first. Trust me, I'm saving a lot of time by doing that. X equals negative b, that's negative 3. Plus or minus the square root. Oh, square root of 1 is 1. So let's just write that now. Square root of 1 all over 2a. 2 times 2 is 4. So that's x is negative 3 plus 1 over 4. That's negative 2/4. Or negative 1/2. We got that answer before. Or x equals negative 3 minus 1 over 4, which is negative 4/4, which is negative 1. We got that answer as well right there. So it all worked out. All's good. You know what we haven't had for a quadratic formula problem yet? You know the whole formula is x equals negative b plus or minus. The b's always been positive, so this was a positive 3x. If it was negative, this would have been a positive 3. Just make sure you know that. Negative b means opposite of 3. Opposite of 3. Now, I will do completing the square because I hate myself. I do not want 2x squared. Let me write this again. 2x squared plus 3x plus 1 equals 0. If you can't get that 2 out of the way on its own, I wouldn't recommend that you do this method, especially when you're going to get fraction stuff here. So I'm going to start by subtracting this 1 over. You don't want it. I don't just take this divided by 2 and square it, not as long as this has a 2. I'm going to force factor the 2 out of here. So I'm left with 3/2 here. Inside here, I'm going to complete the square. On this side, I'm also going to add the same thing, but it needs to multiply by 2 because this number here will also be multiplied by 2 when all said and done. So what number is that? We do 3/2 divided by 2. That's the same as multiplying by 1/2, so you get 3/4. And you square it, so you get 9/16. Notice how I am using fractions. I think it's most preferred. So you multiply 9/16 by 2. Now this factors, this is where it's nice. This is just the 3/4. So the 2 stays on the outside. This factors into x plus 3/4 quantity squared. And negative 1 is going to add with 2 divided by 16 is 1/8. 1/8 times 9 is 9/8. So what's negative 1 plus 9/8? That's negative 8/8 plus 9/8, which is 1/8. If I divide both sides by 2, remember that's the same as multiplying by 1/2. I feel like I'm saying something. Oh, no, I'm not. I've got to take a square root. Multiplying by 1/2 there, and you get 1/16 on that side. So x plus 3/4 squared is 1/16. Now I get to take the square root of both sides to try and solve here. The square root of 1/16 is root 1 over root 16, so it's 1/4. So x plus 3/4 equals plus or minus 1/4. If I subtract 3/4 from both sides, I get x equals negative 3/4 plus or minus 1/4. It's a common denominator, so we can either get negative 3/4 plus 1/4, which is negative 2/4 or negative 1/2. Or you can get x equals negative 3/4 minus 1/4, which is negative 4/4, which is negative 1. Same answers. Do I recommend it? No, not completing the square. That's a big So I prefer factoring. Quadratic formula worked just fine. Factoring is really the bee's knees for me, though. Honestly, I don't even write these steps myself. I just go straight to that. So it's kind of up to you what you want to do. Factoring's my guy. Completing the square. Notice I was a heavy advocate. I pushed for completing the square quite a bit in the right circumstance. This is not the right circumstance. Okay, let's keep moving forward. 2 more questions, starting with number 22. The length of a rectangular prism is 4 times its width. All right, a length is 4 times its width. The volume of the prism is 380 cubic meters. Find the length and width of the prism. So we get a height. Prisms, although you learn them in a future chapter, probably one of the last chapters, prisms are length times width times height formula. So I can say volume is length times width times height. Now, if I replace length with 4W, and I replace height with what you see there, 5, you end up getting a way of saying, oh, and volume, by the way, is 380. You end up getting a fantastic simplified expression that will end up saying 20W squared, 5 times 4, W times W, 20W squared equals 380. Divide both sides by 20, you get W squared equals 19. That's not a great number. Take the square root of both sides, you get W equals plus or minus square root of 19. Now, widths cannot be negative. They can be irrational, I suppose. So the width is root 19 meters. Now the length is 4 times the width. So the length is 4 root 19 meters. I want to make sure I didn't screw anything up along the way. I very well could have. But let's go and check that out in the calculator. We don't need a calculator. Volume is length times width times height. Let's just make sure that everything calculated right. 4 times 5 is 20. Root 19 times root 19 is 19. And 20 times 19 is 380. Was that what we needed? Yep, 380 cubic meters. Sorry if I said square meters earlier. I very well may have. But 380 cubic meters, that all checks out. But that's the final answer, width and length of the prism. Last question, number 23. According to the picture, you cast a fishing lure into the water from a height of 4 feet. Oh yeah, the word problems. Above the water. The height, h, in feet of the fishing lure after t seconds can be modeled by the equation h equals negative 16t squared plus 24t plus 4. After how many seconds does the fishing lure reach a height of 12 feet? After how many seconds does the fishing lure hit the water? So from a graphing standpoint, from a visual standpoint, I should say, here's you, fishing lure, da-da-da. And it looks like a gun. And let's see, fishing lure. And cast off. So this is 4 feet. That's a huge 4 feet. Oh my gosh. Huge 4 feet, and there's the water. Maybe I should have made the drawing because that didn't help anything. This equation can be modeled by, of the lure, h of t, it just says h, but h of t is negative 16t squared plus 24t plus 4. They're asking you, hey, when the height is 12, how many seconds have gone by? So for part A, let's let h of t equal 12, and therefore have an equation that says negative 16t squared plus 24t plus 4 equals 12. And we're solving for t. We're solving for t. It is a quadratic. I don't know which method's best yet. Probably not completing the square. So I'm going to subtract 12 over to begin with, and I'm going to do some other fancy stuff. That's minus 8. I can divide everything here by not just 8, but negative 8. I want this a term positive. Absolutely. Get a positive 2t squared plus 3t and, minus 3t, excuse me, and plus 1 equals 0. And we just saw something factor like this. It was 2x squared plus 3x plus 1 on a previous page. This factors into, this is factorable. This factors into 2t minus 1 times t minus 1. I said I do this thing faster sometimes. Add 1 divided by 2, you get 1/2. And here you get 1. So after half a second and 1 second, the lure is 12 feet above the water. By the way, the equation models everything that we really need to know about this thing. I didn't mention that, but they gave you the equation. The equation shows the plus 4 as being the height above the water, the initial height at time 0. Negative 16 is a coefficient that has to do with acceleration of gravity on Earth when it comes to feet and seconds. And 24 is actually the initial velocity of you casting off for the upward velocity at least. It goes at 24 feet per second initially. So all that's being accounted for in the problem, and we're trying to find that height of 12. Apparently, half a second in and 1 second in, that's like the half a second and 1 second, you get a height of 12 feet. It's probably right near the top of that thing. That's part A. Part B, after how many seconds does the fishing lure hit the water? Now we want to set our height equal to 0. We will get 2 solutions, but only one will qualify. The one where t is positive, not the one where t is negative. So let's go ahead and find out what we're looking for there. Let's set that same equation equal to 0. Negative 16t squared plus 12t plus 4. Was that it? Yes. Set equal to 0. I can divide everything here by negative 4. I get 4t squared minus 3t minus 1 equals 0. Is that factorable? I think it is. This factors into, if it's factorable, I'm going to take it. This factors into t minus 1 to the 4t. So negative 4t plus t is negative 3t, yes. So this is factorable. And t here would either equal negative 1/4, which I'm just going to go ahead and rule out. We're not dealing with that one. I wanted to make that red. Try it again. Or t equals 1. So after 1 second, we hit the water. That doesn't make any sense because we got 1 second here. How can you be 12 feet above the water and hit the water at the same time? Did I do... Oh, that's not a 24. That's a... Oh, that's a... Hold on. Back up. That wasn't a 12. That's a 24. Let's try that again. I don't know why I thought that. Well, maybe it won't be factorable anymore. Okay. Maybe that was just coincidence. It was factorable. Let's do that again. Divide everything by negative 4 even still. 4t squared minus 6t minus 1 equals 0. It's no longer factorable. Okay. Fun the first time. Apologies. Not proper. Good thing I had the other answer to back myself up. Sorry for you guys screaming at your monitor. Hey, we do have a negative b. Listen, it's not factorable. I'm going to use quadratic formula. So we'll start with b squared minus 4ac, which is 36, plus 16, which is 52. Here's the first time, instead of x equals, I'll write t equals. For the first time, our negative b, negative 6, the opposite of negative 6 is positive 6. So I'll get to that stage. Plus or minus square root of 52 all over 2a, 2 times 4. So this becomes positive 6 plus or minus, it's 2 root 13. But here's the thing, I'm going to be rounding this answer anyway, whatever I get. All divided by 8. I could even reduce the fraction, but here's the thing. I'm still going to use the calculator anyway. Divide everything here by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. You're left with 1 root 13, and 8 divided by 2 is 4. Those are two answers. Now, one of them will be negative, the one that I should probably be ignoring. So 3 minus root 13 over 4 is the one I'm going to ignore. 3 plus root 13 over 4 is the one I'm going to use. Negative time does not apply if time was not part of the model prior to casting your reel. So I'm going to do, in my calculator, 3 plus the square root of 13, all divided by 4, and this is 1.65. What do I round to? I'll just do 1.65. 1.65 seconds. That makes more sense. It should be after the 12 feet that we hit, which means it should be more than 1 second later. Not much later. Very weak cast off. So after 1.65 seconds, your fishing reel should pretty much just hit that water. Okay. And that was the last question. So guys, that ought to do it for this one. This is Mr. Robinson. Thanks so much for watching. That actually ended up going a lot longer than I anticipated. A lot of it is me teaching. If I do the doing, it'll probably take under 20 minutes. But y'all, I hope that was very helpful. Check the description section down below if you want to find anything else regarding this stuff. And y'all, take care. I will see you. I'm saying y'all a lot. I will see you, y'all, in the next one.